Okay, let's start with the for geeks question. Okay, let's read the question. You are given an array, a doubler of integers, like number of coins in a pile. You are also given an integer k. Your task is to remove the minimum number of coins. It's the absolute difference between the number of coins in any two updated piles. Okay, any two updated piles at most k. Okay. Here every element is same, so the answer would be 0, and here any two, right? So the array is 1 5 1 2 5 1. So if I'll just take the difference of 1 minus 5, absolute difference of 1 minus 5, it is going to be 4, which is greater than 3. Okay, so if I'll just remove or add coins, I can add, right? uh, your task is remove the minimum number of coins. Okay, I just have to remove the number of coins, right? So if I'll just remove from 5, if I just remove one coins, so yeah, that should if I'll just remove 1 coins from 5, 1 4 1 2 4 1, so the absolute difference will be between any two element as smaller than or equal to 3. So okay. Mm, can I just see the complexities? Okay, auxiliary space should be O of 1. Time complexity O of n log n. So we can like n log n. So we can kind of sort the array, right? Yeah, we can do that. But what is the need of sorting the array? Let's just think of that. 1 5 1 2 5 1. 1 5 1 2 5 1. If we'll just keep track of the numbers, which is greater than the minimum element, or we can just sort the array 1 1 1 2 5 5. Okay, and after that we can just map the indices of each other, or we can use the upper bound function. Yeah, we can do that rather than keeping a map. So the main thing is to find the number of coins, right? Difference between the coins, how many. Okay, like it is showing or not? Yeah, it is visible, I guess. Okay. So what I have to do is I just have to remove 1 coin each from both the piles containing 5 coins. Then for any two files, the absolute difference. If I just sort the array, it will become 1 1 1 2 5 5. Can we do something like minimum heap, keeping one? No, how I'll get the elements which are greater than one? Okay, one brute force approach is I can keep a minimum heap, and or I can keep a element. I can check for each of the elements, like I can start by 1, and if I'll just check that how many elements are greater than 1, and uh, to make the absolute difference, like if it is 5, or if let's suppose if the array is somehow like would look like this, or I can just add the element 7 8 9 7 8. Okay, let's just suppose the array is this. So after sorting the array, I'll get the array would be like 1 1 1 2 5 7 2 5 7 8 9 7 8. Okay, so this is going to be our new updated array. So after this, how many elements are greater than 1? Like how many elements absolute difference from 1 is greater than 3, because we want to minimize or just keep the absolute difference smaller than or equal to 3, right? So 5 minus 1 is greater than 3. So 1 2, 3, 4, 5, 6. Okay, 7 should be here. And okay, let's just you understood the approach, right? We just have to check for each and every element. And like for 7, how many? I'll just subtract 7 from 1. 7 minus 1 is 6. And how much uh, coins we have to remove from 6 to make it smaller than or equal to 3? So it is going to be 3. So we'll add 3 it on add 3 in our answer. That is going to, like, we will do this for each and every element. So it is going to take O of n square time complexity, and which is not what we want to do. Because the time complexity is O of n log n, right? So we can do something like using prefix sum to keep track of all the sum that we have been got before the elements. Let's suppose the sum here, the summation array would look something like 1, 2, 3, 5, 10, 17, 17 plus 7 is 24. 24 plus 8 is 32. 32 plus 8 is 40, and 40 plus 9 is 49. Okay, so this is going to be our prefix sum array. And for each and every element, I'll just check that at which index, like in this case, at which index the element's absolute difference is greater than the given k. Okay, let's see at this index. Like the element is 5. From this index, each and every element will have a difference which is greater than 5, right? Which is greater than k, right? So what we'll do is we'll just keep track of all the sum, and we'll decrease the extra sum that we have been got from this array and add it into our answer. So I'll just code it right away, and I'll explain it in the coding part only. Let's start with the coding part. First of all, I have to just make a prefix sum. Okay, for and I'll just keep the first element as prefix sum dot pushback a double r of 0. Let's keep and also equal to a double r dot size. Okay, I'll keep adding the sum. Okay, for auto or and I is equal to 0, I is smaller than n, I plus plus. I'll just keep adding the sum. I is equal to 1. Prefix sum dot push back, or prefix sum of I is nothing but uh, prefix sum of I minus 1 plus a double r of I. Okay, and I'll initialize prefix sum as n, and I'll just prefix sum of 0 is equal to a double r of 0. Okay, this will give us the prefix sum of the complete array. Yeah, here we'll get the prefix sum of the entire array. After that, what are things that we need? First of all, the variable to compute the final answer, final or minimum coins to remove, minimum coins to remove is equal to, let's suppose, int max. Okay, and uh, for each and every element, suppose for this example, uh, let me just show you. Let's suppose for this example, let's suppose I'll start from 1, and uh, like around 1 the answer is not coming, the answer is coming around 5, or the answer is coming around 8. So what I will do, I also have to keep track of all the elements or all the prefix sum or all the coins that I have before 8, right? So keeping track of all the uh, coins that I have before also. So I'll just write before before coins is equal to let's write it as 0 for now, and for int I is equal to 0, I is smaller than n, I plus plus. Okay, so if I is greater than 0, then only we have to just keep uh, before coins is equal to prefix sum of I minus 1, right? And also uh, Uh, I just have to let me write it here. I just have to keep track of three things, right? First of all, uh, extra money, extra coins, or extra money. Let's suppose extra money. The second thing is money to be removed, money to be removed. Okay, uh, two things I have to calculate, and the main thing is how I'm going to calculate that. So the extra money I can calculate it as simply int extra money. First of all, I have to find the position, right? To find that, I just have to find the position. So position, this POSI position. So int position is equal to this will give me the upper bound a double r dot begin plus I comma a double r dot end, and the condition will be simply of getting the mm, a double r of I plus k minus a double r dot begin, right? Okay, let me just see if I'm not wrong. And position is equal to upper bound half I. Okay, I'll use the upper bound. I think I'm visible. Yeah, I am visible. Great. So int position is equal to upper bound a double r begin plus I, and it will begin. Okay, I'll get the position. Now I have to find two things. First of all, I just have to calculate the money, that the extra money. Okay, so int extra money is nothing but prefix sum of n minus 1 minus prefix sum of position minus 1, right? So this will give me the extra money that I have. Also I just need to find the money to be not removed. I'll just say it like what are the coins they should actually have, right? Money they should actually have. So I'll just write it here. Int uh, um, or expected money, or actual money. Let's just write it. Actual money is nothing but I'll just do it as n minus position into how I'll calculate the. I'll just decrease the, just remove that part before that part. Also, with this, I have to keep track of the elements, right? So in that range, I just have to do is what? Uh, I'll just add the element. The allowed coins, I have to keep track of that, right? Uh, so it is going to be a double r of I plus k. Yeah, simple as that. Okay. So now the money to be removed. Removed coins is nothing but we'll just add the previous money, that is before coins plus the actual coins and okay. uh, Extra money, and we'll just remove the actual money. Okay, and we'll just update the answer. Minimum coins to remove is nothing but minimum coins to remove, comma, the removed coins. Okay, also we can do something like suppose there are duplicates in the array, so we'll just remove the duplicates. Okay, if I is greater than 0 and a double r of I minus 1 is equal to a double r of I, so we'll just continue. So it will continue, save us some time and just help with the answer. Okay, return. Yeah, let's see if this code is working fine or not. There may be some compilation error. Yeah, position, bro, position. Okay, let's check for another custom out input. Let's check for this one only. Okay. uh, okay, I have to remove this, also this, and let's check for this. uh, huh, the output should be 0. Okay, let's check if this is working fine or not. Okay, I thought so. mm. Let's see where I'm doing wrong. If I is greater than 0, before coins is equal to prefix sum of I, and position is equal to upper bound a double r dot begin, a double r dot end. Mm, mm, let's see. Let me just see out. Okay, yeah, upper bound. Uh, why it is running for only one time, bro? Why is greater than 0 and a double r of I minus 1? Don't tell me this is the error. Uh, Okay. Nah, not okay. Mm, come on, man. Where is the error, bro? Where is the error, bro? Expect output is 3, right? Let's just the updated one. Yeah. So there was some issue with. This should work. The idea was fine. There was a simple issue with the prefix sum because it was going out of bounds. So yeah, I think that's totally fine now.